I hope the material is visible to you, isn't
Yes, sir.
it? So, yesterday we just concluded that non-recursive DT-LTI systems, they have impulse response that has a finite duration. Therefore, non-recursive and finite FIR, these two terms are used interchangeably in the literature. So in many textbooks, you will find a chapter on designing of non-recursive filters, and in some textbooks, the same thing is repeated under the heading designing of FIR filters. All right, they mean the same thing. Well, what about the IIR filters, or what about the recursive filters, recursive systems? Before that, there are some more points to observe. Some more points to observe here. So this is the representation of an FIR, or you may say non-recursive system, DTLTI system, given by that equation, yn equal to summation over I equal to 0 to m gi x n minus I. Isn't it? These gi's are nothing but this beta I divided, gi is beta I divided by alpha 0. So that is gi. Do you agree with this statement, this equation? Just cross-check when we were discussing about the FIR system, not the non-recursive system. We had a similar expression here, isn't it? Summation over I equal to 0 to k minus 1 gm x n minus m. Same thing. If that is correct, this is also correct. Now, if you take the z transforms of both sides of this equation, you get an expression for yz. So what's the expression for the transfer function? Gz equal to yz by xz. So that is the transfer function, expression for the transfer function. So it is simply, you can see here, it is simply the z transform of gn or z transform of gi, same thing. If I just blow it up, this summation term, summation expression, it is g0 plus g1 z to the power minus 1 plus g2 z to the power minus 2, etc. up to gm z to the power minus m. So it is these terms in z to the power minus 1, you can think about these terms as g1 by z, g2 by z squared, g3 by z cube, etc. So where are the poles of the transfer function located? Remember that we are considering here a causal non-recursive or FIR system. So that is the expression for the transfer function. So where are the poles located? In this case, poles of the transfer function. পোলগুলো কোথায়?
GL equal to 0.
Yes, all the poles are located at the origin. All the poles are located at z equal to 0. And because this is a causal system, obviously the poles lying inside the unit circle, they imply that this system under consideration, it's a stable system, Bibo-stable system. Thus, FIR or non-recursive systems, they are inherently stable. This is a very important merit of these FIR filters. All right. They are inherently stable. Now, regarding the implementation of these causal FIR or these non-recursive systems, this is a possible structure. You know that representation of the algorithm by means of unit delay elements, adders, and these coefficient values. This is referred to as structure. So most popular structure for implementing, or rather the simplest structure for implementing a FIR or non-recursive system, that is this, what is known as tapped delay or transversal structure. So there is a chain of unit delay elements, as you can see here. And from the input and output of every chain, a tapping is there. A tapping is there, as you can see. So these are the weights or the sample values of the impulse response, G0, G1, G2, G3, up to Gm. So Xn is multiplied with G0, Xn minus 1 is multiplied with G1, Xn minus 2 with G2, etc. And all these products, they are added to yield Yn. Hope this is in agreement with what we have seen. All right. If that is the expression, then what will be the, if you just blow it up, G0 xn plus G1 xn minus 1 plus G2 xn minus 3, xn minus 2, etc. So that is the tap delay or transversal structure for this non-recursive or FIR system. So note down these points. এটা তো লেখা হয়েছিল, এখানেই বোধহয় শেষ হয়েছিল নাকি?
হ্যাঁ স্যার, হ্যাঁ।
স্যার এখানে মানে যেটা লেখা আছে যে all poles of GZ are located at Z equal to 0, so this causal FIR systems are inherently stable, এই লাইনটা স্যার বুঝতে পারলাম না ঠিক।
Causal FIR systeমের ক্ষেত্রে, in case of causal FIR or non-recursive systems, because the poles are located at 0 irrespective of the coefficient values, so all causal FIR systems, they are stable. Inherently তে আপত্তি কেন তোমার? Inherently মানে, inherently means in case of IIR systems, there are lots of things to, I mean, whether the ROC lies in this on this, I mean, the unit circle circumference lies on the ROC or not, etc. So no such deliberation is necessary because it's a causal FIR system and the poles যত ধরনের FIR system পাবে, যত মানে কোএফিসিয়েন্ট ভ্যালুস গুলো যাই হোক না কেন, অর্ডার যাই হোক না কেন, প্রত্যেকটা স্টেবল হবে। কাজে আমরা বলতে পারি ইন জেনারেল দিস ক্লাস অফ সিস্টেমস দে আর ইনহেরেন্টলি স্টেবল।
আচ্ছা স্যার, হ্যাঁ মানে পোলগুলো যেহেতু মানে অরিজিনে আছে তাহলে এখানে আর যেটা মানে সেটা জিরোর থেকে বেশি হবে, মানে একের থেকে কম হবেই সব সময়, এটা মানে বলতে পারি। আচ্ছা
হ্যাঁ, এটা তো অবভিয়াসলি ইউনিট সার্কেলের ভেতরে থাকলেই স্টেবল হবে।
হ্যাঁ স্যার,
তো অরিজিনে আর থাকবে মানে স্টেবল হবে। এখানে তো কোএফিসিয়েন্ট ভ্যালুস উইল নট ডিটারমাইন দ্য স্টেবিলিটি, order of the system will not determine the stability.
আচ্ছা।
In the next section, I have tried to highlight the difference, essential difference between non-recursive and recursive discrete time LTI systems. It's known to you, but I'll just trying to summarize and add a few more points for your consideration. হয়ে গেছে তো?
স্যার হয়ে গিয়েছে।
Say I have tried to depict the differences in the form of a figure. As you can see here, be careful to note that capital F is not Fourier transform operator, nothing to do with Fourier transform. F is simply an operator. The system processes the samples. First, the non-recursive system. The system processes the current and previous m number of samples, input samples, at every instant of time, all right, to yield the output. Whereas in case of recursive system, the bottom one, at every instant of time, the system processes, acts upon, all right, or operates on the current and a few previous input samples and some of the already computed output samples. So those are computed, those are obtained at every instant of time to yield yn. All right. Therefore, for the realization of this system, the recursive system, feedback is necessary. Feedback through delay elements, that is necessary. How many feedback paths will be there, that depends on the order of the system. All right. So I have noted down here the fundamental difference. Fundamental difference lies in the absence of the feedback loop and presence of the feedback loop in case of recursive system. Its absence in case of the non-recursive system and its presence in case of the recursive system. All right. So in absence of these delay elements, there wouldn't have been realized, the system couldn't be realized. Now, another important difference is that all along we have concentrated on digital filters or discrete time systems for online or real-time application. For a while, if we shift our attention to offline processing also, we will observe this, what I have written down here as another important difference. So in case of offline processing, what happens? A large number of data, all the data that have come in, they are stored in some memory location, bulk memory location. All right, from that bulk memory device, at some appropriate instant of time, you carry out processing by using a discrete time LTI system. Then the choice of the origin n equal to 0, that rests on you. So you will have computation of computation involving samples to the left as well as to the right. Now, essential difference here is that suppose we want to compute the output yn0. So this is the output at the instant n0. When it is excited by an input applied at time n equal to 0. If system is recursive, then what can you do? For computing yn0, you have to compute y0, then y1, then y2, then y3, then y4. In this way, you will reach up to yn0 minus 1 and consequently to yn0 for a recursive system. For a non-recursive system, it need not be in this sequential manner. All right. You can compute yn0 immediately without computing the previous previous output samples. That means you can compute y100 first, then y0, then y3, then y4, like that for non-recursive systems. Because all samples xn for all values of small n, they are already present and you are aware of their presence, their values are known to you. So that's why that can be done in case of recursive system. All right. So that is the implication. Whereas for a non-recursive system, output can be computed in any order. This has relevance only for offline processing, remember. In real-time processing, even if it is the system is non-recursive, then you don't compute in this way. y100 first, then y25, then y2, then y50. Such a situation will not arise in case of real-time signal processing. But in case of offline signal processing, this may be helpful in certain practical applications. No further details will be considered in this connection. All right. Okay, write down. If you have any question, just let me know. presence of the delay feedback, presence of the feedback path that has an important bearing on the performance, on the real life performance of these systems, the recursive systems. If there is some nonlinear element present in the delay element, then that type of system may exhibit strange behavior, and in certain cases they may become unstable. When considering about stability, we have not taken into account these nonlinearities. And of course, that is not within your scope of discussion or already, although I will exhibit some cases, a couple of cases where presence of nonlinear element in the feedback path is giving rise to certain strange behavior. Why am I raising this issue? Why at all will the nonlinear element be present in the feedback path? I'll try to highlight that soon. তোমাদের কি 12টা থেকে ক্লাস আছে কোনো?
স্যার 12:30 থেকে আছে।
ও আচ্ছা, ঠিক আছে। W oblique O means without.
Sir, please scroll up.
Yes.
Okay, sir, now scroll down. Sir, please scroll up. Okay, sir.
Sir, have you told that the discussion about this non-recursive system that output can be computed in any order is only valid for offline signal processing?
Yes.
Okay, sir.
কারণ অনলাইন সিগন্যাল প্রসেসিংয়ে তো স্কোপ নেই, তোমার তো
হ্যাঁ স্যার।
ডেটাগুলো আসছে, তোমাকে তৎক্ষণাৎ সিস্টেমটার একটা আউটপুট থ্রো করতে হবে।
হ্যাঁ।
Come to now the impulse response of recursive systems. The difference equation representation of the recursive system is given in equation 4. So on the right hand side, you have two summations. The first one is the non-recursive portion of the output, the first summation. And second one is the recursive portion of the output. So for such a filter, for such a system rather, we wouldn't want it, will not be using the term filter for the time being. For that type of recursive system, if you just excite the recursive system by a sample sequence or impulse sequence, xn equal to delta n, then obviously in this expression, in equation 4, you have to replace x with delta and y with g. So that will be the expression for the impulse response sequence. Now, that summation di delta n minus I, you know that for n not equal to I, for I not equal to n, delta n minus I, that will be 0. Only for I equal to n, delta n minus I will have a value of 1. So in this summation, only the term bn will be there. All other terms will be 0. But second term is here. All right. Here there is a mistake. It shouldn't be yn minus I. It should be g. ai gn minus I. Just let me correct it. Now from the equation 5, can you infer anything about the duration of the impulse response? You cannot say anything clearly about the duration of the impulse response, although this recursive term, the summation recursive term, it may remain non-zero even for large indices. The recursive portion will go on generating output long after these bn's have become 0. So long after these bn's have become 0, the recursive portion may still go on generating values so that the duration will be long. All right. But as a matter of fact, the duration actually has an infinite duration. That can be illustrated with the help of simple causal recursive system. The first order system will do that. First, write down this part.
Sir,
Hmm.
so here the first portion of the summation is the non-recursive portion of the output, and the second portion is the recursive portion of the output, right?
Uh.
Yes, sir.
Because in the first summation, no term involving previous output samples are present, while in the second term, the previous output samples are present.
স্যার এখানে জিএন এর যে ফাইনাল এক্সপ্রেশনটা বেরোলো, তাহলে এখানে ওই রেকার্সিভ টার্মটা তো মানে কতটা অবধি থাকবে সেটা তো ডিপেন্ড করবে ক্যাপিটাল এনটা ক্যাপিটাল এম এর থেকে
একদম
কতটা
একদম
বড়।
হ্যাঁ হ্যাঁ হ্যাঁ। n ইকুয়াল টু m এর পরে তোমার আর থাকবে না, n ইকুয়াল টু ক্যাপিটাল M, তাই না?
হ্যাঁ স্যার।
So we are trying to illustrate or examine the impulse response of a simple causal recursive system, the first order system, represented by equation 6. So here also, if you just set xn equal to delta n, and under that condition, if you evaluate the output for different values of n, then you may form some idea about the impulse response. এই দরজাটা খুলে দে, দরজাটাকে একটু খোলো, just 1 minute. দরজাটা all right, so here G0, what will be G0? Causal system, so we should start from n equal to 0. Oh, that expression has vanished. Anyway, just 1 minute. Just 1 minute. Gn to delta n. So this is the expression for Gn. B0 delta n plus A1 Gn minus 1. Now if you just start from n equal to 0, what will be G0? It's B0 delta 0 plus A1 G minus 1. Because it's a causal system, G minus 1 is 0. So it is B0 into delta 0, that means B0. Similarly, for G1, for n equal to 1, it will be, just cross check, n equal to 1 means G1 here, B0 delta 1, that is 0, because delta 1 is 0, plus A1 into how much? G0. A1 into G0 means A1 into B0. So G1 is A1 into B0. In a similar manner, G2 will be A1 squared B0, G3 will be A1 cubed B0, like that. So in general, Gn will be A1 to the power n into B0. And because it's a causal system, just to imply that the impulse response has 0 values, identically 0 values for n less than 0, I have introduced this unit step sequence, un. So that is the complete expression, A1 to the power n B0 un. Clearly, this
So please
expression for
repeat.
Gn.
So please repeat why you have introduced that unit step UN here.
Just to imply that Gn will have 0 values for n less than 0. All right. Because it's a causal system, its impulse response should have, if I left it at A1 to the power n B0, I should have written here for n greater than equal to 0. That should have been the complete statement. But instead of that, I am writing A1 to the power
Yes,
n
yes,
B0
yes,
un
yes, sir.
to imply that it's a causal sequence. So what do you think about this sequence, A1 to the power n B0? Its duration is infinite. All right. So write down this part, then I'll sketch. Then I will have a few sketches of those impulse responses. You have written it, this expression. The exact shape of the impulse response as a function of time, that will depend on A1. All right, that will depend on A1. And the initial value, that means the value at n equal to 0, that will depend on B0. That's নিচ্ছি। So these are sketches of the temporal variation of impulse response. So one is for A1 greater than 1, another is for A1 equal to 1, and third one is for positive A1, but it's less than 1. So what is happening? Obviously, you know, when A1 is equal to 1, Gn will be a step sequence. When A1 is less than 1 but positive, what will happen? It will be a monotonically decreasing function of n. And for A1 greater than n, it will grow with the value of n. So these are the three cases for positive value of A1. So those observations have been noted down here. Now here I have also cited the case for A1 greater than -1 less than 0. That means for negative values of A1. So when that is the case, what will happen? Gn, the impulse response, it will have a value of B0 at n equal to 0. Then it will oscillate. But the oscillation will gradually decrease the amplitude of oscillation and tend to 0. That is because the magnitude of A1 is less than 1. All right, magnitude of A1 is less than 1. For A1 equal to -1, what will happen? It will start from B0, then it will oscillate with a steady amplitude. But in both these cases, it will continue up to n equal to infinity. There's infinite duration. That is the case for A1 equal to -1. It oscillates with a steady amplitude. What is the frequency of oscillation? Frequency of oscillation is 2 into tau. 2 samples, meaning 2 into tau. That is the time period. So Fs by 2 is the frequency of oscillation. It oscillates at half the sampling frequency. Here also there is oscillation. It starts from n equal to 0, has a value B0, then it oscillates. Oscillation frequency remains same, but the amplitude of oscillation grows with time and the sequence becomes unbounded. So that is for A1 less than -1. That means negative A1 and magnitude of A1 greater than 1. All right. Sketch these things and then proceed.
Sir, could you please scroll up?
ছবিটা
না স্যার, ছবিটার নিচে।
Sir, please scroll down.
Yes. লেখা হয়েছে এগুলো? উফ,
Yes, sir.
স্যার এই উপরের পয়েন্টটা একবার দেখাবেন?
হ্যালো, হ্যাঁ, 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 তোমার টিউটোরিয়ালটা পাওয়া যাচ্ছে না, তুমি তোমার টিউটোরিয়ালটা জমা দাও ইমিডিয়েটলি। ঠিক আছে, না না,
এই অবধি লেখা হলে বলো।
হ্যাঁ হ্যাঁ,
আচ্ছা হয়েছে।
So for these figures, I haven't written down the comments, I think, but you should be able to describe it. মনে নেই কমেন্ট গুলো আছে নাকি নিচে? In all these cases, the frequency of oscillation, that is half the sampling frequency. once you complete drawing these figures, I'll try to point out certain very interesting effect. Interesting effect of presence of a nonlinear element in the feedback path.
Yes, sir, done.
Now see here, forget about this coefficient minus 0.9. It can be anything. Say it is 0.8 or 0.3 or 0.02. Anyway, that's first time to try highlight what will happen, this important effect. So this is a simple recursive system, isn't it? Now, what will happen is that, see here, xn is there as one of the input, or say it can be xn into some constant a0. There ওরকম কোনো ছবি কি ছিল আগে দেখে নি আমি একটু এক্সপ্লেন করা সুবিধা হয়। No. এই হচ্ছে মুশকিল, ক্লাসরুম হলে আমি ছবিটা এঁকে ফেলতে পারতাম একটা এক্সাম্পল হিসেবে। Anyway, I am considering the simplest case. So at every instant of time, what is, yes, কিছু বলছিলে? At every instant
Sir, you
of
can
time,
use the whiteboard here.
বাবা সে হাতে আঁকাটা খুব মুশকিল হবে আমার পক্ষে, হোয়াইট বোর্ড আবার কি করে। ছেড়ে দাও, ওটাতে হয়ে যাবে আমার। So say we have an IIR system or recursive system. At every instant, what will happen is that, say if this is the system, xn, say suppose the system is implemented using 2b plus 1 bits. Sorry, b plus 1 bits. Suppose it is implemented using b plus 1 bits. Why b plus 1? Because I am considering that bipolar coding. So the numbers are bipolar, all right? So 1 bit will be either explicitly or implicitly utilized for representing the sign. So that's why we say b plus 1 bit. Therefore, xn is a b plus 1 bit number. Yn minus 1 is a b plus 1 bit number. That coefficient, whatever value it may be, it is represented using b plus 1 number of bits. So here you have b plus 1 bit number. Here you have a product. As the other input, you have a product of two numbers b plus 1 bit values. So when you multiply two b plus 1 bit values, how many bits are there in the product? 2b plus 1 bits. Now, if you have to add this 2b plus 1 bit number to a b plus 1 bit number, this 2b plus 1 bit number, it is to be quantized. It is to be rounded off to b plus 1 bit number. So there is some rounding of element present here. Remember that there is no separate rounding of thing. Now rounding of element. Rounding off is a part of the analog to digital conversion. But for the sake of understanding, I am considering that there is some quantizer here that does the task of rounding off. Now, rounding off operation, it rounds off 2b plus 1 bit number into a b plus 1 bit number. This rounding off operation, whatever may be the nature of rounding off, it is a nonlinear process. It is a nonlinear operation. Why? Forget about these things. Say you are considering, forget about this system. You are considering that any number, it is to be rounded off to the nearest integer. So 2.3 is the input to the rounding off mechanism. Then the output will be 2. If the input to this rounding off mechanism is 4.6, what will happen? You have doubled the input. It is rounded off to 5. So see, you have doubled the input, the output has not doubled. Isn't it? The output has not doubled. So that is the rounding off. Rounding off is a nonlinear operation. So such a nonlinear operation takes place in this feedback path. Here, for this particular example, there is no coefficient attached to xn. All right, simply xn is the input to this adder. If some coefficient was attached to xn, that coefficient would have b plus 1 number of bits. So 2b plus 1 number of bits multiplied will give you 2b plus 1 bits number here. So then also this 2b plus 1 bit number has to be rounded off to b plus 1 bits, and here also 2b plus 1 bit number, it is to be rounded off to b plus 1 bits. But that multiplication of 2b plus 2 numbers b plus 1 bits and rounding off to this b plus 1 bit, that is not so much important as rounding off in this feedback path is concerned. All right. So presence of nonlinear element in this feedback path always, may give rise, may, not always, may give rise to very strange behavior. I have pointed out what may happen. Say the input has ceased to exist. Depending on the coefficient value with which you are multiplying and then rounding off, it may happen that the output, although the input has ceased to exist, the output may continue to oscillate with a steady amplitude until another non-zero input comes here and breaks this oscillation. So that type of a thing is known as limit cycle oscillation, zero input limit cycle oscillation. All right. That may happen here. Another thing that may happen is that due to same effect, the input has ceased to exist. Depending on the coefficient value, it may happen that although the input has ceased to exist, the output, it has got locked at some constant value and remains there. So that is called deadband effect. That is also detrimental for practical applications. So such things can occur in digital IIR filters, discrete time IIR systems. All right. So I am trying to illustrate not the practical situation, say 2b plus 1 bit number, etc. But what I am trying to highlight here is that presence of a rounding off element in this feedback path, a nonlinear element, will generate zero input limit cycle under certain conditions. All right, or may introduce deadband effect under certain conditions. Certain conditions means depending on the coefficient value. So for the sake of understanding, I have considered that this is the first order IIR system. Here this coefficient in the feedback path is negative, say minus 0.9. So that is the difference equation relating output and input. Let us see if we consider that the product of minus 0.9 and yn minus 1, if it is rounded up to the nearest integer, will it result in any strange behavior? For that purpose, we consider that xn is 10 delta n. That means at the instant n equal to 0, xn has a value of 10, and thenceforth it has a value of 0. So just try to find out. I will consider both the values, without rounding off, with rounding off. All right. So y0 will be x0 minus 0.9, y minus 1. So what is x0? x0 is 10. So y minus 1, because it's a causal system, it will be 0. So 10 will be the output. y1 is x1 minus 0.9. Remember that x1 is 0 because it's 10 delta 1. So henceforth, x values will continue to be 0. So y1 is 0 minus 0.9 into 10 minus 9. Fine. y2 is how much? x2 minus 0.9 y1. So that will be minus 7. Minus 9, 8 instead of 8.1. All right. y3, it will be minus 7. Y minus 7, 8 into minus 0.9. That means how much? Minus 7.2, that means minus 7. If y2 had 8.1, y3 would have been minus 7.29. Come to y4. y4 is 6. y4, what will be y4? y4 will be minus 0.9 into minus 7. That means plus 6.3, that means plus 6. If y3 were minus 7.29, y4 would have been 6.561. y5 is 6 into minus 0.9, that means minus 5.4, that means minus 5. Instead of minus 5.9049 if y4 were 6.561. So whatever is there on the right hand side, that has been considered as the output, ideal output value, without any finite number of, without any rounding off. Next is y6. y6 is minus 5 into minus 0.9. That means 4.5 equal to 5 instead of 5.31441. y7 in a similar manner will be minus 5. y8 will be 5 instead of these values. All right. This is not perhaps minus 4.30. This would have been plus, I think. All right. There is no need for computing any further, because if you compute y9, y10, y11, y12, y13, proceed in this manner, the output will toggle between plus 5 and minus 5. Whereas if this rounding off were not present, what would have happened? Just see here. It is oscillating, but it's tending towards, it is decreasing. And in the limit as n tends to infinity, it will decay to 0 because it's an IIR system. But in practice, because of this rounding off, the output is toggling between plus 5 and minus 5. Although the input is absent. Input were there only for the case of n equal to 0. There's a value of 10. Henceforth, input is 0. So just see, this is the generation of zero input limit cycle. What type of detrimental effect can it have? I am saying that it has a detrimental effect. Suppose you are carrying out speech signal processing or audio signal processing. So what you have done, first you have converted that audio signal into an electrical signal by using microphone. Then that analog electrical signal is converted into digital signal using ADC for digital processing. And now suppose you are using this filter to process that digitized version of the audio signal. Sorry. So what may happen is that even if the audio signal at the input, it has become zero, because of this zero input limit cycle phenomena, the output may continue to oscillate at a steady amplitude. And what is the frequency of oscillation? You can easily see frequency of oscillation is half the sampling frequency. That may happen. Now this processed signal yn, it's converted into an analog signal and then into a sound signal. What does that mean? Yn toggles between +5 and -5 at half the sampling frequency. At the output, you will hear, ultimate output, you will hear an audible tone. Although the audio signal right at the beginning that has become zero, because of this zero input limit cycle, at the ultimate output, you will hear an audible tone. So that is obvious what is not desired. Only when another non-zero value of xn comes in, will this zero input limit cycle break. Is it clear? It's not that in every IIR filter it will happen, but the coefficient values may become such that they may give rise to this zero input limit cycle due to presence of the quantizer element in the feedback path. I am harping of round off operation. If it were truncation operation also, that could have happened, because the process of truncation is also a nonlinear process, nonlinear operation. All right.
স্যার স্যার বলছি Y5 এর ভ্যালুটা যদি রাউন্ড অফ না করা হয় তাহলে তো ওটা আসছে -5.9049, তাহলে স্যার ওটা রাউন্ড অফ করে -6 হওয়া উচিত, তো -5 কেন হচ্ছে?
আরে এই ভ্যালুগুলো কি? এই ভ্যালুগুলো হচ্ছে, ধরো এখানে 8.1টাকে রাউন্ড অফ করা হয়নি 8-এ। রাউন্ড অফ যদি না করা হয় তাহলে এই ভ্যালুগুলো কি হবে, yn এর ভ্যালু কি হবে, সেগুলো তো লেখা আছে। তাহলে yn এর ভ্যালুটা কি হবে? 8.1 ইন্টু কোথায় গেল 0.9 -0.9 কত আসছে? -7.29 আসছে। পরেরটা কি? -7.29 ইন্টু 0.9 -0.9, সেখানে 6.561 আসছে। পরেরটা কি? 6.561 ইন্টু -0.9। রাউন্ডিং অফ ব্যাপারটাই যদি না থাকতো তাহলে যে ভ্যালুগুলো হতো সেগুলো এখানে লেখা আছে। বুঝতে পেরেছো?
কিন্তু রাউন্ড অফ তো লেখা আছে রাউন্ডেড অফ টু নিয়ারেস্ট ইন্টিজার, তো -5.
আরে এগুলোকে তো রাউন্ড অফ করা হচ্ছে না, রাউন্ড অফ তো করা হচ্ছে এইগুলোকে। যখনই রাউন্ড অফ আসছে, এই যে 8.1 এর জায়গায় আমরা 8 করলাম, তাহলে পরের y3টা কিভাবে ক্যালকুলেট করব? এই যে রাউন্ডেড অফ y2 যে ভ্যালুটা সেটাকে কাজে লাগাবো, y2 এই ভ্যালুটাকে তো কাজে লাগাবো। বুঝতে পেরেছো?
ঠিক আছে, ওকে স্যার। হ্যাঁ,
8.1 কে কাজে লাগাবো না। এই সবাই বুঝেছো? বুঝে না থাকলে বলো, বলছো না কিছু জায়গায়। Dead band effect due to rounding off. So here what I have done, I have only changed the sign 0.9. Same equation, sign reversed. All right, xn is 10 delta n, 0.9 yn minus 1 is rounded off to the nearest integer. So y0 is 10, y1 is 9, y2 is 8. Proceeding in a similar manner, y3 is 7, y4 is 6, y5 is 5, then it has got locked at 5. Although if this rounding off constraint was not there, then the output have progressively decreased and it will tend to 0 as n tends to infinity. All right. So that is also detrimental in many applications. Not the audio application, but in many other applications. So here I am simply trying to illustrate the effect of the presence presence of a rounding of element in the feedback path, nothing else. When you are implementing the system, rounding off to nearest integer will not happen. But rounding off to a certain number of bits, that may not represent nearest integer. That may happen. So similar problem may crop up. Okay.
স্যার এখানে যে কোয়ান্টাইজারটার কথা বললেন, এটা কি মানে সিস্টেমটার ইনহারেন্ট প্রপার্টি হিসাবে থাকবে, মানে থাকতে
হ্যাঁ।
পারে?
হ্যাঁ হ্যাঁ,
আচ্ছা স্যার।
ওই যে 2b plus 1 bit number that is rounded off to b plus 1 bit number, that is inherent in the system.
ওকে স্যার।
I'll let you scooter.
হয়েছে আশা করি।
Look back to that.
I have only changed the sign of this coefficient, recursive coefficient.
না না হ্যাঁ 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 না না এটা আগে আগে দিয়ে নেই তো
ওখানে গিয়ে একটু কথা বলো না। যদি একটা ক্লোজড লুপ কন্ট্রোল সিস্টেমে ফিডব্যাক এলিমেন্টে নন লিনিয়ার এলিমেন্ট থাকে, সেখানেও এই ধরনের জিরো ইনপুট লিমিট সাইকেল হতে পারে, অথবা ডেড ব্যান্ড এফেক্ট, যাই হোক না কেন। এই প্রবলেমটা আমি জানি না সলিউশনটা ঠিকঠাক করতে পারলাম কিনা। লেখা গেছে এগুলো উপরের? I have a problem, problem here. You are given the structure of a particular discrete time LTI system. So what you have to find out is that whether this when you simplify this system, whether this system can be implemented using only one unit delay element or not. Those unit delay elements, they are represented by those boxes with tau inscribed. All right. How would you proceed with this problem? Give me some idea. কিভাবে গো? হুম,
ইকুয়েশনটা বার করতে পারে এখান থেকে।
হ্যাঁ, here the sequence is xn minus 1. I don't know what will be the sequence there. Then here what will be the sequence? These things are not known, isn't it? So what's the way out? Whether any other information is required or not, let me know first. এই যে এত ট্রান্সফর্ম পড়ছো, এগুলোর কি মানে কখন ব্যবহার করবে সেটাই তো বোঝনি এখনো। For performing algebraic manipulation, you have to move from the time domain to the z domain. So what will be the representation of the system in the z domain? This is the one. So xz, I have replaced yn and xn with their z transforms, xz, yz. Because we are moved on to the z domain, these unit delay elements, each of these unit delay elements, they should be replaced by z to the power minus 1. So that's what I have done. So the signal here in the z domain is pz. The z transform of the time domain signal here at this point is pz. The signal there, it has a z transform sz. Here you have the z transform of the signal present qz. If that is the case, what will be there at the output of this unit delay element? In the z domain, it will be z to the power minus 1 into xz. And here, if this is qz, what is fed back is z to the power minus 1 into qz. All right. Here it's I mean the z transform of the signal present here is pz. So the z transform of the signal present there, it will be z to the power minus 1 into pz. Now can you formulate a set of algebraic equations? Qz, just see, what is qz? It is xz plus z to the power minus 1 into qz. All right. What is pz? Oh, pz এর দুবার ব্র্যাকেট পড়ে গেছে। pz is z to the power minus 1 into xz plus this signal, z to the power minus 1 into pz. Is that clear? That is pz, equation 2. what is sz? Sz is there. So it is 3 times the output of this adder block. The inputs are z to the power minus 1 qz and minus pz. All right. So that add up to give the output here of the adder. That has to be multiplied by 3 to get sz. So sz is 3z to the power minus 1 qz minus 3 pz. Is that clear? And yz is simply qz plus sz. So these equations are all right, or check, just check whether the equations are all right or not. চেক করে বলো আমাকে। ঠিক আছে?
হ্যাঁ স্যার।
So yz is this one. Now from equation 1, the first equation, what do you get? You get, on rearranging the terms, you get qz as xz divided by 1 minus z to the power minus 1, isn't it? Qz equal to xz divided by 1 minus z to the power minus 1. From 2, what is pz? Pz is z to the power minus 1 xz divided by 1 minus z to the power minus 1. All right. From 1, 2, and 3, sz, it will be 3z to the power minus 1 xz divided by 1 minus z to the power minus 1 minus 3z to the power minus 1 xz by 1 minus z to the power minus 1. এটা ঠিক আছে? দেখো, if this is correct, then sz will ultimately become 0. Then sz will become 0. দেখো ঠিক আছে?
হ্যাঁ স্যার।
Then yz is qz plus sz, that means qz. So this is, we obtained qz as xz by 1 minus z to the power minus 1. Now if you take the z transforms of both sides, you will get yn equal to xn plus yn minus 1. So that is the implementation. So that is the implementation using a single unit delay element. Write down this thing. তোমরা সিস্টেম মানে সিগন্যালস এন্ড সিস্টেমসে আমি আর বিজেপি স্যার যে পার্টটা পড়াই সেটা বাদ দিয়ে অন্য পার্ট, যেটা প্রফেসর সায়ন্তন চৌধুরী পড়ান, যেটা চক্রবর্তী, হ্যাঁ, তো ওই পার্টে এই ধরনের প্রবলেম করনি? টাইম ডোমেনে লাপ্লাস থেকে লাপ্লাসে নিয়ে যেতে হচ্ছে, মানে এস ডোমেনে নিয়ে যেতে হচ্ছে।
স্যার আমাদের সিস্টেম পার্টটা অতটা ভালো করে হয়নি আর কি ক্লাস।
কেন, সময়ের অভাবে নাকি?
হ্যাঁ স্যার।
আচ্ছা। বলা যেতে পারে ওটাকে বোধহয় বলে ব্লক ডায়াগ্রাম রিডাকশন। কন্টিনিউয়াস টাইম সিগন্যালের ক্ষেত্রে এই যে প্রবলেমগুলো,
স্যার ওটা তো কন্ট্রোল সিস্টেমে আছে।
ও কন্ট্রোল সিস্টেমে আছে। আচ্ছা আচ্ছা, ঠিক আছে, তার সেই কারণেই ওখানে হয়নি। সেটা এখন পড়ছো নাকি?
হ্যাঁ স্যার।
আঁকা হয়ে গেলে বলো, আমি নিচের গুলোতে যাই। হলো?
ইয়েস।
So if I had asked you to obtain the impulse response of this complete system, then you could have just proceeded in this manner, obtained GZ, all right, and then take the inverse Z transform to obtain the impulse response. হয়েছে? উপরের ফিগারটা বোধহয় অনেকে আঁকতে পারোনি মনে হয়। এটা হয়ে গেলে বলো।
Search.
এটা আঁকতে পেরেছো সবাই? হয়ে গেলে বলো, আমি লগ আউট করব। How will you obtain the Fourier transform from a knowledge of Z transform? If I provide you with the knowledge of the Z transform of any sequence, from that, how will you obtain the Fourier transform?
Substituting e to the power j omega
Right,
instead of z.
instead of Z, right, very good. What condition should the Z transform satisfy? Follow me carefully. What condition should the Z transform satisfy so that the Fourier transform exists?
Sigma equal to 0.
Sigma equal to 0. Which sigma? Or sigma equal to 0 means this real part of S.
Yes, sir.
No, that is all right. But what condition should the Z transform satisfy? Z transform or its ROC satisfy? Can you comment anything about the ROC of Z transform or the existence of the Fourier transform? What was the condition that had to be satisfied by signals, continuous time signals, for the existence of the Fourier transform? The signals should have been
The
absolutely
ROC of z
integrable.
transform, yes. And for
Should
the
have been,
ROC of z transform, it has to be inside the unit circle.
the unit circle should lie in the ROC. Circumference of the unit circle should lie in the ROC. Fourier transform means the Z transform evaluated on the circumference of the unit circle. If you evaluate it on the circumference of the unit circle, it means what you were saying earlier, that sigma is 0. So Z transform evaluated on the circumference of the unit circle should have a finite magnitude. That means the circumference of the unit circle should lie in the ROC. So only then the Fourier transform will exist. Because for existence of the Fourier transform, the sequence has to be absolutely summable. For continuous time signal, the condition was absolute integrability. Here the condition is absolute summability. So absolute summability means the summation of this sequence xn from n equal to minus infinity to plus infinity, summation of magnitude of xn, sorry, that should be finite, less than infinity. Therefore, that is another condition, and this absolute summability and the circumference of the unit circle of the z plane lying in the ROC of xz, they are essentially same manifestations of the same thing. Okay, so if you have drawn it, let us stop today. So I'm logging out. Huh? Okay, you log out first, then I'll log out.